Hello, I'm Dr. Ian McCullough, and in this lecture, we're going to be talking about applications of artificial intelligence. So, this is not meant to be a holistic set of all applications of artificial intelligence. I'm just going to talk to you about some of the most common areas, and then please have an open mind and think about other ideas on your own. That would be ideal. The first area that we're going to be talking about is computer vision. So computer vision is any kind of seeing task. If I'm going to be doing things like object detection, right? Like what's that barcode on a package, or is that a truck or a car on security footage? It could also be facial recognition. Can I identify the difference between Bob and Sue on video? Object tracking. Can I look at an object tracking through my assembly line or a vehicle moving? Object tracking. Basically, anything where you can see the object and make sense of it or reason about it is the area of computer vision. The next and possibly larger application area is natural language processing. This is anything with words. So it could be sentiment analysis, like is this document positive or negative, or is this tweet positive or negative? It could be topic modeling. What's the document about? Machine language translation. Can I move from English to another language, right? Like, pick your language. So anything with words would be natural language processing. Graph analytics deals with relationships when data is related in some way. So a lot of times it would be like recommender systems. So when you see social media recommend a new friend for you, when you see Amazon recommend a new product for you, that type of AI is driven by graph analytics. It's also involved for any kind of knowledge search. So when you go to Google and you type in a search term and it's recommending what web pages to go to, that's an example of a knowledge graph search, right? Which is graph analytics. It can also be used in these other applications of NLP and computer vision to, they call it dimension reduction, but it's basically reducing the cost and computational complexity that you would have in actually doing those tasks. So it is applied to a lot of other areas of AI as well. Data classification. This is kind of identifying types of data. And again, that can help with things like search and data management. It can also identify anomalies, right? Like if you think about a manufacturing line, you might have tooling that wears or tooling that breaks. Can you identify that quickly based on some sort of data-driven process so that you can stop the process and not waste a bunch of time, material, and resources producing stuff that you can't sell at the other end, right? So that data classification is important. Also, it's used for identifying malicious actors on your network. It's or other security applications. There are many, many applications for data classification. Forecasting. This is helping us plan, schedule, reduce anomalies, assess our programs. Again, this is just looking at data and then forecasting what it's going to be. It's more of a data science application, but they can also be improved with AI. Autonomous robots. I'm sure we've seen the autonomous cars. People have heard of Tesla and many of the other vehicles. Companies are doing the same thing. So self-driving vehicles. But there's also manufacturing applications for autonomous robots. Operating in hazardous environments. In Iraq, we used to use robots to go and disarm improvised explosive devices, so we didn't have to put a human in harm's way. So there's a lot of applications for autonomous robots. Generative AI probably needs no introduction. My personal belief is that we use generative AI to spark creativity, to automate some of the creative process as opposed to completely replace it. But it is going to have this phase over the next few years of people understanding how to best use that technology and improve it. And then the last one is symbolic AI, which, as we talked about in the history of AI, was probably one of the more original forms of AI. But it's been, let's say, the hype around generative AI and probabilistic AI have gained so much attention. People have forgotten about some of the benefits symbolic AI can apply. And so, there's applications we can do there. dealing with like mathematical proof to eliminate the needs for testing, right? If you can mathematically prove that it's accurate, you don't have to have a bunch of people testing a fraction of the space if you could automate proving that it's good across the enterprise. So let's look in more depth at computer vision. So again, this is a field that's enabling computers to get meaningful information out of images, videos, or other visual inputs. So we talked about the deep fakes. So what you're seeing here is a lady that is creating a deep fake of Arnold Schwarzenegger. And so you see her yelling, and you see Arnold Schwarzenegger yelling in the output video, but it's basically making her facial features and voice look like that of Arnold Schwarzenegger. That's a deep fake. There's an application I did for government dealing with warehouse utilization. So if we can equip cameras to forklifts moving about a warehouse, can we use computer vision to measure warehouse utilization? We were able to reduce inventory costs by half. So we were able to be significant better at warehouse utilization and reducing costs in inventory management. Tracking, right? So you've seen barcodes on packages, right? For many shipping industries, right? At Accenture, we consulted the U.S. Postal Service, FedEx, UPS, DHL. A lot of them are using barcodes as a form or other types of tracking to track packages. In the upper right here is a project from a hazard monitoring application I did. So when there was an area in the U.S. with seasonal flooding, applications like Waze or Google Maps would route first responders in emergency situations through highly flooded areas because that's where there was fewer traffic. So what we're doing is using satellite imagery to detect where the flooding is, making those no-go areas for emergency traffics, and then creating a rapid rerouting algorithm so that we can help route first responders. It also allows us to forecast what we think future flooding would be in an area. So as you're making contingency plans for where to house first responders, you can place them in hotels and areas where they have maximal access to those people that would be in need, identify cut-off communities so you can actually better prioritize first responder needs. So that's an example of computer vision. In the lower left is an example of detecting disinformation. So we can actually look at objects, and what you're seeing is in one image, you see that there's a normal wake from a boat. In the other one, there's no wake. And so that those types of cues can help us detect disinformation or mistakes that people have in fake information. Biometrics is another one. Can we either improve on tracking individuals based on the gait or based on patterns in their walk or other types of biometrics, or how do we actually improve that task? Data generation, can we create synthetic environments? I talked a little bit earlier about how we're doing that for exposure therapy and PTSD treatment. Data annotation, can I get better at labeling the data to improve my machine learning algorithms? And then the last one that's a common application is for safety, right? Can I have cameras that are overseeing factory floors identify potential safety hazards to either alert somebody to take some intervention? We did this for Disney World, for example, where when you look at some of the rides, we'll have, at least there's a pilot, I don't know that they're actually using it now, but in the pilot, we could actually monitor people going through the ride. And so if there was a safety hazard, it would alert a central operator to shut down the ride or pause the ride to prevent injury to a person. And it could even alert people. So, they have very distinctive uniforms at Disney World. So if somebody walked away from the control station with a shutoff, it could alert a central actor to be monitoring through the camera in case a hazard occurred that required a central intervention while the attendant was attending to it. And so those ways we can improve worker safety. Some applications of natural language processing, topic modeling. So what you're seeing here is in a series of text or tweets, in this particular example, there are different clusters, which you're seeing on the left, and some of those clusters are overlapping. The overlapping clusters allows you to kind of create a bar chart of what the key topics are that people are talking about. In this particular case, just the fact that you have such high overlapping, tightly overlapping clusters indicates the presence of disinformation or fake narratives as well. So that's a part of topic modeling. We can classify sentiment. How are people responding to your brand or to an incident? maybe something, there's like a flashpoint in media, and something happens, like there's an oil spill. How are people responding to the oil spill, for example? Machine translations we talked a little bit about, right? You can translate in from one language into another. That's getting better and better and better. Typically, what I've done with machine language translation is I will use it to create the initial text. So I want to have a narrative that I'm translating into different languages consistently. I can do that to get the raw text and then have a native speaker go through and correct it. What you find is translation is a very difficult task, even for fluent bilingual speakers. But if we can use the machine language translation to get to the starting point, it's a lot easier for them to go and make sense of it. So that'll lower your cost in translation activities. Entity recognition, so being able to identify known entities in reporting. One particular application is if I have a bunch of news reporters that are reporting on different stories, and there's a ton of them, or social media reporting on events, can I identify key terms, classify them together with some sort of graph analytic, and then be able to do topic modeling to understand what are the people talking about in that discourse? What are the key entities that people are referring to? Helps me identify what are the key stories that I need to pay attention to. Spell checking is an application of natural language processing. Search, speech recognition. So when you're pick your Internet of Things device that's going to listen to your voice and respond. That's part of speech recognition. And it can even identify speaker IDs. So some companies are using your voice as a password now. So we turn to graph analytics. A lot of social networks get done here. So this would be social network analysis centrality, identifying opinion leaders in text or in groups. We also use this for organizational design. We can identify clusters. And, in a social dynamic, the presence of a cluster of people is a statistical anomaly. There is a reason or a factor that drives that. It could be shared interest in hobbies. It could be language similarity. It could be proximity. It could be some sort of reciprocal behaviors that happens. There's something that drives that. And so by identifying the clusters, it can give us insights into a lot of those organizations. Recommender systems, like how do we actually get information or innovations to the most people? It's common in fraud detection. So being able to look at patterns of nefarious behavior for taking advantage of people or fraud. This is common in banking. It's common in taxes, in criminal defense, in a number of different fraud type applications. It's also highly used in supply chain. So if we can model the supply chain as a network or as a graph, we can identify areas where we are wasteful in that supply chain and lean it out, or we can identify areas where we're fragile and build in robustness. It's also a very common use in cybersecurity applications. In the cybersecurity thing there, you're seeing an email network of IP data going across different hosts on a small network. And so we can identify clusters of normal behavior. That also allows us to identify anomalies much faster. We also use it in bioinformatics for improving healthcare and just general process improvement. For data classification, we have applications of data management, document retrieval, information security. Even when you filter your email is a data classification problem. CRMs use data classification to kind of make sense of clients and improve your customer management, customer interaction. We also use data classification in fraud along with graph analytics. There's a lot of healthcare applications. And I'd point out that this image was created with generative AI. Here's another generative AI image. But forecasting, we use forecasting a lot for sales and demand. For maintenance, predictive maintenance. That was one of my first consulting activities was a cold storage company, and they had to look at predictive maintenance so that could they determine what refrigeration units needed to be repaired when or maintained when, and could we then be intelligent about how we were storing inventory. So you start emptying out one refrigeration unit and filling up another so that it's ready for the predictive maintenance. Resource consumption, financial markets. Everybody tries to use AI forecasting in some way to predict the stock market. Generally, that does well. Some are more clever than others, but there's competition for it. So once one person comes up with a clever approach, everybody does. We use forecasting for traffic management and transportation. It's usually not as lucrative in city planning, but it's more common when you're actually looking at mapping out airline routes or how we're going to do supply chain logistics. We also do healthcare and forecasting. I mentioned earlier some of my organ transplant work, so being able to forecast mortality slopes, patient outcomes under different scenarios is helpful. Website traffic routing is often done with forecasting, and how do you optimize traffic to your website for sales? And the last one would be, how do you actually estimate the costs in cloud resources for your AI projects? With interactive chat, there are a number of cloud-provided solutions. So I'm just showing you the common ones there from Amazon, Google, Microsoft, and HubSpot. But you can create real-time two-way communications that's automated with an interactive AI, and that is helpful for call center operations, digital marketing and e-commerce, sometimes for education, providing students faster feedback, appointment scheduling. So you can either send people reminders, you can automate the scheduling of your appointment. You don't have to have a person doing that. There's also some applications in entertainment and media. Think about video gaming and that sort of thing. And then for technical support, you can either give customers direct technical support or help your technical support help desk agents get access to the information to help people. Autonomous robots. This is probably more what you think about with AI and robotics, but there's applications in manufacturing, in the agriculture industry, logistics and warehousing. I showed you an example of where we're using computer vision with autonomous robots to actually map out warehouse utilization. But it also can be done for claims processing. Can you pre-read claims applications, make sense with them, and reason with them with perhaps greater consensus than humans on the outcomes of those claims? Now, I'm not saying you would necessarily want to use an AI to deny somebody's claim, but what if you can get the yes claims out of the system faster and more fairly and get benefits to people that need them quickly? We use them in retail, military and defense uses autonomous robots, like the example for bomb diffusion or things like that, so you can reduce putting people into harm's way. There's a lot of back office automation, ordering, going through any of that monotonous work. Even some of the data management, data integration can be done by autonomous robots. Now, that's not a physical robot. That might be a robot that's completely virtual on the machine doing some sort of cognitive task. And then also transportation. In the community that I live in, there's an autonomous bus called Beep that goes by the community center and takes people down to where the restaurants and bars are in the evenings so that they can reduce the likelihood of drunk driving in our neighborhood. Generative AI. Generative AI is generating new content. So a lot of this is done for just general content creation. We use it for data augmentation. So if you want to increase the volume of data to train an algorithm, and maybe a certain area of the data is imbalanced, so that's going to create bias, we can generate data that looks like it to kind of balance out the outcome so that we can get better performance evaluation. We see generative AI in extending deep fakes and synthetic media. So you can think about avatars that are operating in virtual environments. You can think about, in Hollywood, there was a big uproar about using generative AI for writing scripts or for creating actors, so you don't have to pay actors such high salaries. Game development. In creative design, what we find is if you actually have a model for understanding influence, you can use that to guide your prompts in generative AI to create really good starting content for campaign ads, media ads, marketing. And then you're asking your creative staff to just get that starting point and fine tune it and make it a little bit better. And that seems to be the trend of where humans and machines are operating together given the rise of generative AI. Generative AI can also help personalize the media to a certain demographic if you're less familiar with it. We're using generative AI in creating simulated training environments. So if I want to train people like marketing execs on how to respond to hot topics on media, can I simulate people's response to kind of help them learn to not say something that's going to go off in a negative direction, if you will. We're also using generative AI for drug discovery, for that type of innovation. So can I learn from successful drug patents, and can I generate new ones that might be better? Part of our ability to accelerate the development of COVID vaccines in such a short time. You might have heard it was like 20 years they were working with mRNA unsuccessfully, and then COVID happens and they figured it out in a year. Well, under that pressure, they were much more willing to adopt AI accelerated methods to generate more likely outcomes so that we're actually doing clinical trials and testing on more successful variants. So that's how that is being used. I'm doing research right now on automated vulnerability detection and repair in cyber using generative AI. But in this particular case, I'm not using probabilistic generative AI as much as I'm using symbolic AI, symbolic generative AI. So we're actually using that to make mathematically provable, accurate fixes for the vulnerabilities. And so symbolic AI is this idea that's using symbols and formal logic to reason about data. And so it can improve fast, accurate data integration. It can migrate queries. So if you're going from, like, say, an SAP instance with high license costs to like a Snowflake implementation where they're going to give you credits and lower cloud costs, well, you can move all the data, but all your queries and all your dashboards and all of your insight tools were written to that legacy system. So how do you generate the transfer from legacy to next gen? Well, symbolic AI can do that. If you were to use a generative AI that's probabilistic, you would find that it's prone to hallucination and errors and mistakes, and you have to manually test a fraction of the possible space to see, hey, did this happen correctly? And then if it doesn't, you have tremendous risk. Well, with a generative symbolic AI, you can actually do that translation and mathematically prove that it was done accurately and you've introduced no new errors. And so it is what I would argue a generative AI risk mitigation tool. It also allows you to optimize cloud. So instead of having all these random instances of the cloud, you can derive what the unique, most efficient minimal data warehouse is, so you can get much more efficient in your cloud compute costs and storage costs and kind of identify where there's potential errors. Now, some clients are using that to just simply do quarterly reviews of their existing systems so they can identify problems and be more focused in how they respond to potential risk and problems. And other people are doing full automation with symbolic AI. So this has been a lecture on potential applications of AI. I hope you found it interesting. I more hope that you are opening your mind to potential use cases and applications. And as we get into the case studies, I'm looking forward to hearing your thoughts on how you can extend AI even further.